This video tutorial presents a generic experimental procedure. Please consult your class notes for term-specific instructions. In Part 1 of this two-part lab, microprocessor heating is simulated using a micro-integrated heater/temperature sensor on a silicon chip. The temperature coefficient of resistance, or TCR, is determined by investigating the relationship between sensor resistance and temperature. How can we accurately measure resistance? A standard ohm meter measures all the resistance in the circuit, including the wires. Although wire resistance is typically small, significant error can occur when measuring components with low resistance. A 4-wire probe provides a clever solution by measuring the current of the forcing signal with an ammeter and independently sensing the voltage across the sensor with a voltmeter. Sensor resistance is easily calculated by applying Ohm's law. The lab setup for this experiment consists of an ammeter, a power supply, a hot plate, a handheld thermocouple meter, and a voltmeter. The silicon chip containing the sensor is mounted to a copper bar and instrumented with a thermocouple to measure chip temperature. The resistance of the sensor is sequentially measured over a range of 30 to 150 degrees Celsius at increments of 10 degrees. A voltage bias, either 100 millivolts or 1 volt, is applied to the sensor throughout the experiment. Power up the digital multimeter. Set to current mode, i.e. ammeter, by pressing the blue shift button, then the DCI button. Press the main button on the power supply. To set the bias voltage on the sensor, press the +6V button, then toggle the output on. Use the left-right arrow buttons to move the cursor position and then turn the dial to change the value. Initially, set the bias voltage to 100 millivolts. Do not exceed 5 volts, which will permanently damage the chip. For the handheld multimeter, turn the selector dial to V to display voltage. Press the on button on the thermocouple meter and then select T1 or T2 corresponding to the connected channel. In this case, the thermocouple is connected to T2. Turn on the hot plate and adjust the set point temperature. The set point may be set slightly higher than the target temperature to improve the heating and/or ramp-up time. The hot plate will become very hot during this experiment and can cause injury. Avoid all contact with the hot surface. Once the target temperature is attained, measure and record the voltage and current of the sensor. Continue to progressively ramp up the temperature. Measure and record the voltage and current at 10-degree increments. After recording the voltage and current at 150 degrees, reverse the direction by cooling down the chip and taking measurements every 10 degrees. Continue until the temperature has returned to 30 degrees. Repeat the experiment at a bias voltage of 1 volt. Multiple runs at varying voltage bias should be conducted. Plot the relationship between sensor resistance and temperature. From this plot, the temperature coefficient of resistance, or TCR, is determined from the slope of the linear region. This value will be applied in Part 2 of the lab. When finished, be sure to shut down all the equipment. In particular, verify the hot plate is off before leaving the lab.